Good morning. Today we're going to look at Unit 4, Lesson 3, the ambiguous case for sine law. So before we get into the ambiguous case, we're first going to recall what can be found based on certain information we're given and what law do we use to find that. So the first thing is if we're given two angles and any side, what can be found? Well, we can find the side opposite any angle. Because if we're given two angles, we should be able to calculate that third angle and then find the side opposite it using an angle side pair. So what I mean by that is if we have, let's see, we have two angles. We have angle A, angle B, and then we're given some other side, like let's say we're given side C. Well, we can calculate the other angle, right? So as soon as we have two angles, we can calculate that third angle, and then we've created an angle side pair. So now we can compare that to another angle side pair to find the other side. So we can find the other side opposite any angle, and we would do that using our sine law. All right, if we were given two sides and the contained angle, then we could find the third side. So two sides and any contained angle, that's side angle side, we're going to use cosine law. If we're given three sides, well obviously we've already given all three sides, we should be able to find an angle. And with side, 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 we use cosine law to find one of those. Finally, if we're given two sides and an angle opposite one of them, well, an angle opposite one of them would mean that we have an angle side pair. So as soon as we have an angle side pair, we can find the angle that's opposite the other side. Okay, and we're going to use sine law to find that. All right, so we're going to get into this idea of the ambiguous case for sine law. And the ambiguous case for sine law says whenever you want to use sine law to determine an angle, so only when we're trying to determine an angle, when you're given side-side angle, you need to consider the ambiguous case. The ambiguous means that something is unclear or inexact because a choice between alternatives has not been made. So we're going to test for the ambiguous case. I'm going to talk to you a little bit about what that means. So if we were to calculate the height of the triangle given here in our diagram using the given angle, and then we'll compare the known side lengths to the height. So if we were given triangle ABC, where angle A is 45 degrees, okay, and side length B is 20 centimeters, we need to calculate this height. So this is side length B. Right, and then we have side length A over here, which we could say is the height of the triangle, right? We've created this right triangle. So if we want to find this side length A, well, we have a right triangle here. So to do that, I'm going to take the sine of 45, which is going to be equal to my opposite side over my hypotenuse. Well, my opposite side in this case is h over my hypotenuse, which is 20. So I'm going to isolate for the height and move that 20 over to the other side by multiplying it. So 20 times the sine of 45 equals the height, or h equals 14.1 centimeters. So if we were going to generalize the equation for how we just calculated our height, what we did was we took the sine of A, which was 45 degrees, and that was equal to side length A over side length B, right, where A was our height. So if I started working to isolate my height, I'm going to move my B over to the other side of the equation. So B times the sine of A equals A. And I'm just going to write this with my A on the other side of the equation. So A equals B times the sine of A. And then finally, what does A equal? Well, A is our height. So if I wanted to calculate my height, I can replace that little a with height. So the height is equal to B times our sine of A. So we're going to use that. That's kind of part of our ambiguous case as we move forward. So let's look at some different scenarios to test for this ambiguous case that we're talking about. So in this first example, we're going to compare the triangle we're creating to that right triangle that we looked at just above here. So we're going to stick with this 45-degree angle. And we have a side length of 20. So that's all the same from above, okay? So knowing that information, we know that the height of that triangle is 14.1 centimeters, all right? So it says solve for angle B if triangle ABC is defined by an angle A equal 45 degrees, side A is 13 centimeters, and side B is 20. So we already know our side B here. That's the side opposite angle B. They're saying side A is 13, so they're saying this side over here is 13 centimeters. So this example says if the swinging arm, or side A, so remember this is side A, of the triangle is less than the height of the triangle, then no solution exists. So think about side A as almost like this swinging arm here, right? If I have this arm, I'm trying to create an arm that's long enough to make another triangle, right? So I want to make a triangle like that. But right now, side length A is shorter than the height. So if it's shorter than the height, it will never reach the base of the triangle, right? 13 centimeters is shorter than 14.1. So if swinging arm is less than 14.1, it won't touch the base to create a triangle. And we're going to prove that algebraically now. So if we were going to use that information and try to find our angle B, because it says to solve for angle B, I'm going to set up my sine law. So I know my sine law is A over, actually, we're doing the setup for finding an angle. So we're going to do the sine of A over side length A equals the sine of B over side length B. This would be the sine of A is 45 degrees over our side length A, which they said is 13, equals the sine of B, which is what we're trying to find, angle B, over side length B, which was 20. So I'm going to multiply that 20 over to the other side. So you have 20 times the sine of 45 over 13 equals the sine of B. I'm going to take the inverse of both sides to move that sine over. So I'm going to move this sine over to this side. So we'll have the sine inverse of 20 times the sine of 45 divided by 13 equals B. So if I plug all that into my calculator, there's 20 times the sine of 45 divided by 13 and take the sine inverse of it. If you plug that in your calculator, you're going to find that B equals an error, right? So that really means no solution exists. So this just proves the point about if our swinging arm is shorter than our height, which we found our height to be 14.1, then no triangle can be made because that swinging arm is never going to touch that base and create a triangle. All right, so that's the first idea of our ambiguous case. When we're given that information, we're given side angle. If that side opposite the known angle is shorter than the height of a right triangle that we could make, then no solution exists. All right, so let's look at another situation. Let's look at another situation in which one triangle might exist with this side angle information. So it says if the swinging arm of a triangle is equal to the height of the triangle, then only one solution exists. Okay, so in this case, the swinging arm, so here's my swinging arm, right? If it's equal to the height, then it's going to sit right on top of that height, right? If my swinging arm is equal to the height, then it's going to make a right triangle like this. So it says with the swinging arm being equal to the height, it will only reach the base of the triangle once, when it is perpendicular to the base, making a right triangle. So that's one situation. Another situation in which we'll only have one triangle is if the swinging arm is greater than or equal to the other known side. So if this is greater than, right, we have this side being greater than, it says that, solve for angle B again, if triangle ABC is defined by that information we already know here. So angle A is 45 degrees. This time it says side A is 25 centimeters. So we can see side A is bigger than our height because we know our height, we've already calculated it, is 14.1. And it's also bigger than our known side over B, which is 20 centimeters. So if this was angle B, then side B would be over there, all right? So think about this swinging arm. If I tried to take this swinging arm and swing it through, keep in mind it's 25 centimeters, so it's longer than this 20 centimeters, right? It's gonna swing through right by that 20 centimeters before it lands. It's never gonna touch that base of the triangle, but it's gonna go all the way through to the other side and never create another triangle. So you're only gonna have one triangle that's going to be created when the side is that big. So let's take a look at that. So we're going to again set up our sine ratio and we're trying to find angle B. So we'll say the sine of B over side length B is equal to the sine of A over side length A. And then we'll plug in what we know. So we don't know angle B, but we do know side length B is 20. And sine of 45 degrees over side length A, which is 25. So I'm going to multiply that 20 over to the other side of the equation. And then I'm going to take the inverse of both sides to isolate B. So you're going to have the sine inverse of 20 times the sine of 45 all over 25. So when you calculate that, you should get that angle B equals 34.4 degrees. And again, you're only going to have one triangle created. So you're going to create this oblique triangle, this non-right triangle, like that. All right, let's look at one more scenario. This is the one that really is the ambiguous case. So in this next example where you're going to end up with two triangles, again, we're using the same information where we know angle A is 45 degrees and side length B is 20 centimeters. So it says, if the swinging arm of the triangle is greater than the height, so still greater than the height, but less than the other known side, then two solutions exist. Okay, so it says with the swinging arm being greater than the height, it'll reach the base of the triangle twice. So think about our swinging arm here, right? We have this swinging arm. And if we were to swing this arm through to the middle of the triangle, it's going to swing back up and hit the base of the triangle again there. creating yet another triangle. So we're going to have a triangle like that. But then we're also going to have a triangle like that. So you're going to have that green triangle that's on the outside, but if we swing that arm through, we're going to create another tiny yellow triangle there with a very acute angle at the top. So we're going to look at how do we define both of those, because we're going to have two different angle B's that now we're solving for. So let's call this bigger triangle, oops, I grabbed my highlighter. Let's call this bigger triangle with an angle B. We'll say that this is B1. And then when we swing our arm through over here, it's going to create another triangle. We'll call that one B2. All right, so let's start by solving what is this angle B1. So we'll set up our sine ratio again. So the sine of B, we'll say B1, over side length B is equal to the sine of A over side length A. And in this case, our side length A is 15 centimeters. Remember that we've already found the height of our triangle, right? The height of our triangle was 14.1. Okay, so we'll plug in for this green triangle to start with. So the sine of B is equal to, or sorry, sine of B rather, over side length B is 20, is equal to the sine of 45 degrees over our side length, which is 15. We're going to multiply that 20 over to the other side and take the sine inverse. We'll do that all in one step. We'll take the sine inverse of multiplying that 20 over to the other side times the sine of 45 all over 15. And remember, this was all that angle B1. So when we calculate that, we should find that that is equal to 70.5 degrees. So once again, I'm just going to draw this triangle that goes along with this, kind of break those two triangles apart. So we have 20 centimeters for side length B. We have 15 centimeters for side length A. We know angle A is 45 degrees, and we just calculated that angle B1 is 70.5 degrees. Right? So that's that green triangle. If we wanted to look at this yellow triangle, so if I drew this yellow triangle, it's kind of a skinny little triangle that looks something like this. Right, we have this second B angle we've created, but we already know some of this information as well. We know angle A is 45 degrees. We know we have 20 centimeters here. That swinging arm doesn't change its length, right? So it's 15 in the bigger triangle. It's also 15 when it swings through to create that smaller triangle. So now we have to think about, well, what is angle B in this situation? So I know that this one was 70.5 degrees. Well, when I swing that arm through, these two angles are going to be the same, right? That angle is still 70.5 when it swings and lands on the base. So I should be able to find the angle on the other side of that by looking at its supplementary partner, basically. So I broke that yellow triangle out. We know that this is 70.5 degrees. So to find this angle here, we're just going to subtract that from 180. So those two angles are supplementary. So we could say that that angle B2 would be 109.5 degrees. And you can see that that angle is rather obtuse, so it makes sense that it's something bigger than 90. So we've found two angles now that are a possibility for angle B based on the information provided. So we can say, therefore, angle B is 70.5 degrees or 109.5 degrees. So let's summarize all of this ambiguous case information with just a little chart. So whenever you have two lengths and an angle, so when you have side-side angle, Right, side to side angle. You need to check for the ambiguous case of sine law. And the way we check for that is we're going to find the height, which remember our height is b times the sine of a, and then compare it to those side lengths a and b. So the no triangle situation we looked at first, if a, which is that side opposite my known angle, if it is smaller than my height, so if I was just going to draw that in this diagram here. So if I was to draw A here off of C, right? I'm going to really make it dramatic. If A is less than my height, we can see from that, then we don't create any triangles. It never touches the base. If A is equal to our height, right? So that, remember, that situation where it's perpendicular, it's right on top of our height. Then we just create one right triangle. When we make two triangles is when we have A is going to be less than B. So I'm going to create A. That looks like it's a smaller than B, but it's greater than our height. So you can see it says our height, and then the swinging arm is greater than our height, but less than our other known side. So A is bigger than our height. You can see from the drawing that it looks longer than our height, but then if I swing it through, I could create another triangle like that. All right, and then something to remember is that those angles, because those two side lengths are the same, are going to be the same, which will help you determine some of your measurements in that second triangle created. And then finally, if our swinging arm is bigger than our other known side, so let's make that really dramatic. So it's bigger than our other known side and it's bigger than our height, something like that. Only one oblique triangle is going to be made because I can't swing that side through and create another triangle. It's going to swing right past side length B over here somewhere, right? It would be like somewhere way over here. I'm never going to touch the base of that triangle. So you only have one triangle when side length A is bigger than the other known side. So that's the situation if angle A is an acute angle. So that's when it's acute or less than 90. That example we used in our notes, we had a 45-degree angle, right? So that's the situation there. If our triangle is obtuse, meaning if angle A is bigger than 90, we'll kind of just talk about what will happen. So again, if our swinging arm, if A is smaller than the other known side, so if B is our other known side and we say A is smaller than that, so say that's A, then again, we can't make a triangle. It's never going to touch if it's shorter than B. But if angle A is obtuse and side length A is greater than B, right? Side length A is greater than B, then you're going to have one obtuse triangle. So this takes some practice in getting used to using this chart, but we're going to look at one example for our notes today. Okay, so we're going to take a look at this note. So it says triangle ABC is such that A is 22 centimeters, B is 27 centimeters, and angle A is 40 degrees. Find all possible lengths of side C. So we're going to go ahead and label this triangle just like those other triangles were labeled, just to compare using that sine law. So let's say this is A, B, and C. All right. So angle A is 40 degrees. Side length A, which would be over here, is 22 centimeters. And side length B is 27 centimeters. So they're wanting us to find all possible solutions for C. All right, so we need to first figure out, well, what's the height of this triangle? If I was to draw the height, I need to know what the height is so then I can compare if side length A is bigger than or smaller than that height. We can see it's smaller than my other known side, so we're going to find the height. And remember, the height is B times the sine of A. Okay, so we're going to find the height to test for ambiguous case. So height is equal to B, which is 27, times the sine of A, or the sine of 40. So the height equals 17.4. right? So the ambiguous case states that the height, or b times the sine of a, if it's less than a and a is less than b, then you're going to have two solutions. So we'll say is b times the sine of a less than b? Well, is that the case? Let's take a look. So b times our sine of a was 17.4. Side length a is 22. And side length b is 27. So is this true? Yes, it is. So therefore, there are two solutions, or two triangles. So let's explore the first triangle we created, which will be this bigger one here. All right, and we need to figure out, I'm going to break it out like this. So we have A, B, C. Just going to label all that information we already had for our side lengths and our angle. So they're wanting us to find all possible lengths of side C. So I don't have any information for C yet, but I can use my sine law to find angle B. So that's what we'll start with. So we'll take the sine of B over B equals the sine of A over A. So we'll plug in the information we have. So side length B is 27, and then we'll do the sine of A, which is 40 degrees over 22. We're going to cross multiply that 27 over to the other side. And then finally we're going to take the sine inverse to move that over to the other side of the equation so B is isolated. So the sine inverse of 27 times the sine of 40 all over 22. So angle B will equal 52 degrees. All right, so we know that this angle here is going to be 52 degrees. Okay, I'm going to pause the video. The question is asking you to find side length C, so we need to find this side length down here. So you go ahead and use your sine law to continue with this problem and figure out what is side length C, and then we'll come back together and look at that other triangle. All right, so if you continue on working through your angles and sides, you should have found that angle C is 88 degrees, and then we used that with our sine law and found that side length C was 34.2 centimeters. So let's look at the other triangle created. We'll set it up, and then I'll have you guys work to solve for C. So this other triangle created would be this little acute one here. All right, so we know that the swinging arm, if it swings through, then this arm is going to be 22 centimeters as well. So if we were to draw that triangle, draw it over here, look something like this, where you have A, B, and C, and we'll label all that same information we have, where angle A is 40 degrees, side length B is 27 centimeters, side length A is 22 centimeters, and we're trying to find side length C. So there's some more information we can find here. First of all, we found the angle B in that bigger triangle was 52 degrees. So if that swings through over here, then that exterior angle on the smaller triangle will be 52 degrees. So this will be 52 degrees. So then we can find that obtuse triangle angle by subtracting it from 180. So 180 minus 52 is going to be 128 degrees. Now that we have that other angle B, go ahead and use your sine law and the other things we know about triangles to work through to figure out what is side length C going to be. Pause the video here and then you'll see the solution when you return. Okay, so if you work yourself through that, you should be able to then calculate your angle C is 12 degrees by taking 180 and subtracting the other two angles we know in this triangle. So we know angle A is 40 degrees and angle B is 128. So angle C will be 12 degrees. Then once we have angle C, we can use our sine law to find that missing side length C, and you'll find that it is 7.1 centimeters. So if we just wanted to conclude our findings there, we could say, therefore, side length C is 7.1 centimeters or 34.2 centimeters. An ambiguous case says it can be either. That's it for your notes for today.